Okay, well, we seem to have a good number of people joined us already, so I'm going to get started. Welcome to this Cirrus Link webinar, No Code, No Fuss, Digital Transformation and the Connected Factory in Minutes with Ignition and AWS. You're probably here today because you work for a company that has a process that is used to generate revenue, or you provide solutions to a company like that. That process could be a factory production line, a stamping machine making connectors, an oil well lift pump, food and beverage production line, or even a logistics distribution system. By monitoring these processes and comparing information over time or against other locations with similar processes, we can notice patterns and find ways to increase productivity. We've also heard that with powerful machine learning tools can predict when a piece of equipment is going to fail or how a process can be tweaked to significantly improve operational efficiencies. But to date and in practice, this has been too complicated and expensive and prone to common failures. Well, today we're going to show you just how easy it is to share operational data with IT services with no coding and no fuss, and in literally a few minutes be sending your OT data to the cloud where the powerful tools from Amazon Web Services or other third-party applications can achieve these operational improvements and drive increased revenue and profits. My name is Chris Houghton, and I'll be serving as the moderator today. With me is Arlen Nipper, President and CTO of Cirrus Link, and co-inventor of MQTT, the lightweight publish-subscribe messaging protocol. Also with us is Kurt Hoeknedel, Sales and Marketing Director at Cirrus Link, and we're very excited to have with us Thomas Cummins, who is a Partner Solutions Architect with Amazon Web Services. He will show us some of the amazing tools that are available to discover the true value of your OT data in AWS. First, a little background about Cirrus Link Solutions. Founded in 2012 by Arlen and myself, we have over 80 man years of experience in-house implementing solutions using MQTT. Our MQTT modules enable the Ignition platform to connect OT data to IT services for big data analytics, while providing a superior OT solution. Cirrus Link developed the Sparkplug specification, which has been open sourced through the Eclipse Foundation and is rapidly becoming the de facto standard for open interoperability within the industrial market for hardware and software manufacturers. We are one of only 2 strategic partners to Inductive Automation, who created the Ignition platform for SCADA and MES. We have extensive experience in designing and implementing MQTT solutions. So we've seen a lot of challenges and concerns that people typically have about using this technology and solved them previously on actual projects. In this hour, we'll start with a review of what is a digital transformation and what are some of the typical problems and challenges faced by people trying to implement. Then we'll have a quick look at the MQTT and Sparkplug as the underlying technologies that are used in our solution before showing how we need to define the model at the edge as close to the process as possible. Then, with no code and no fuss, how this OT data is automatically pushed to the cloud into AWS SiteWise, where Thomas will show us the powerful tools AWS has to maximize the value of the OT data. Lastly, we'll have a demo showing the end-to-end solution, followed by a Q&A session. So if you have any questions as we go through the presentation, feel free to post them into the chat window and we'll answer as many of them as possible at the end. So without further delay, I'd like to hand over to Kurt Hoeknedel to get us started. Over to you, Kurt.
Thank you, Kurt. So it's been kind of interesting in the last, especially over the issues that we've had globally in COVID. But what's been kind of interesting is the amount of companies we've been talking to increasing their remote monitoring and their IoT applications and really looking at trying to do digital transformation during this downtime and increasing getting value from their systems. And a lot of them are driving for these very benefits of trying to how can they reduce costs, get a quicker ROI, transform their business, get more data, use their resources better, and really gain insights on their applications, doing predictive maintenance, asset management, machine learning. All these tools are really becoming the forefront of what corporations are trying to implement. And really trying to open the door to get the globalization of their data products across multiple factories, multiple applications, multiple systems into a centralized repository so they can start acting on the data and basically transform their business from a standalone, independent application to more of a global reach and understanding of their overall business as a whole. And then with them trying to do this, they're trying to overachieve some hurdles that they're seeing. That's seen in this industry of trying to how can we actually do this digital transformation in an effective manner that's scalable, that can be achieved more easily and repeatable across these factories as implementations. And a lot of these goals that they have is how can we bridge this OT-IT gap? How can we get this data from these operations into system architectures that can be easily consumed? And they're trying to do it where it's, the problems they've had is, most of the stuff has been done with, I'd say standalone approaches where they, put a solution at the edge and, write some custom code. And it's really not, cost effective. It's not really scalable, as they find out on the OT space that, not any one factory, any one location has been implemented the same. So every situation is different and it's not really easily modifiable to bring it into these different bridging the OT-IT gaps. And they get to deal with the interesting proprietary nature of all these different protocols, all these different industries that are in the OT world. So what they see when they're talking to some big SIs, or they're talking to people like Thomas, is they have this proposition of, okay, we have all these tools in the cloud that provide all these services and values, and these will actually gain the insights you want, perform that digital transformation to enable your business to start achieving the goals that you want to become better as an operational company. And it looks simple. And then as they go into it, they'll spend months trying to get this data across, and they'll find out that the OT world is not what they thought it would be from the standpoint of IT, who don't really necessarily understand the multiple protocols, the different nature of the businesses, and it becomes very, very, very difficult. So the reality sets in. This is not a simple solution, and that's what we're here trying to solve. And the reason is because there's not really a conflict between the operational world and the IT world. It's just that they see things differently in their operational environment. OT data, consists of proprietary protocols based typically in the nature of the business they're in, whether it's a type of PLC or device. It has different data formats that are not, consistent across different applications. It's typically not contextual, meaning it's really just a tag value. It could be just a value of a pressure, a value of, it's a very straightforward, like a Modbus representation of some IO points. It's designed for operations. It's a critical path. It's safety path. It's mission critical. Those are the high constraints of it. Every industry has a different kind of set of its own protocols and natures. If you're using industrial controls, you have PLC protocols. If you're doing building operations, it's BACnet. If you're doing oil and gas, you're going to have some EFM protocols, some other devices, and they're all different. Most of it's pull response. It's tightly coupled between the SCADA system and the devices in the field, and it's mostly isolated. So that OT consists of that. IT always consists of data objects, data modeling, stated data formats across different enterprises. A lot of it's RESTful and JSON. It has contextual information, has other information that's valuable to the operations, to the IT environment, so they can understand what the data represents. It's decoupled, it's pushed across. You have ERP systems, you have enterprise mobile communications, there's publish subscribe. It's it's easy to integrate and secure within its environment. So you have these two things we're trying to bridge, and that's what we're trying to solve from the standpoint. It's just that there's different worlds and how they are investigated. So what's kind of interesting, and what we've seen is digital transformation, is basically starting to utilize an MQTT. And MQTT, being it was designed originally for a real-time system using pub sub architectures, but it's been really growing, increasingly growing in the industry from an IT perspective. And the reason it is because it's a pub-sub architecture. It's message oriented. You have a decoupled system where data can be pushed by one system to multiple systems, and it's kind of ideal for that, the nature of sharing data across multiple architectures. The thing is, it's as a design factor, and using MQTT when it was originally designed, was we want to keep it simple. It's really easy to implement. It's not a very hard protocol. It's a transport layer protocol. It's very simple. You have a topic namespace. You have a published payload that can be pretty much anything, and it's really easy to implement on a sensor to a PLC to a. It's not something that takes a lot of time and engineering to build. It's efficient. It's report by exceptions. Uses low bandwidth. It's stateful, which is very critical in OT world. So you need to know the health of your communications from the devices in the field, and it's open. It's no vendor lock-in. And so when when MQTT was invented, it had all these open standards. The problem was that when it was invented, is that we have all these corporations, all these different applications built in implicit topic namespaces and how they actually implemented it, how they implemented MQTT to work within a specific device and a specific application, and there was no standard from a standpoint of interoperability. So when Cirrus Link set out to define a standard called Sparkplug, or Sparkplug B, 3.5 years ago, and push it out to the Eclipse Foundation as an open standard, we wanted to utilize what MQTT did, a very simple, decoupled, interoperable, stateful protocol, but build a standard on it, a specification that provides some contextual information so that if I'm a client and I push this data out in a Sparkplug format, other applications can easily consume the data and understand exactly what is being pushed without actually have to have an implicit contract between an application and a client. So what it does is it just defines that OT-centric topic namespace that everybody can utilize. It defines that data model. It defines a payload that's using Google protobufs, and a binary payload is very efficient. It has a state management that basically tells you in an OT world the health of the connection. If my device is offline, online. It provides the data that you can describe a compressor value with its engineering units, its scaling, its asset ID. So you can now provide a data model to this information. It supports report by exception and control. And one of the critical things is that it supports auto discovery. An initial connection, it does a birth certificate. It tells all the devices and all the applications, hey, here's a new device, here's all the contextual information. So you have auto discovery. It also has the source of truth, which means that you configure this at the edge where the client is, and that's where the data is described, and that is pushed up throughout the whole system, whoever wants the data. And it also has store and forward for applications that come, that get decoupled from the network. So if you do lose communications, it basically can save that data, and when it reconnects, you don't lose any data. All critical for doing digital transformation. So with this, I'll pass it on to Arlen to start talking about SiteWise.
Thanks, Kurt. So I'll get a little bit of background on this. So we've been working with Amazon and customers now for about 4 years with different digital transformation projects. And one of the interesting things is that initially we were just taking process variables, key value pairs, and putting those into data lakes, into like S3 buckets. And we found that it was a lot of work to try to keep those measurements, if you will, associated with where did they come from, associated with where is their contextual data live. So I had the opportunity to meet Thomas and some of the Amazon team when I got to do a tour of one of the Amazon fulfillment centers, which was fantastic. That was back in the days when we could travel, actually. And I was explaining to Thomas what we were trying to do, and that we were maybe developing some lambdas so that when a new asset or model was published, we would put that into DynamoDB, and that way we would have a reference to these tags that were in a data lake, and then be able to put all that together. And Thomas said, well, Arlen, that kind of sounds like a product that we're working on called SiteWise. And so I was introduced to SiteWise about a year ago before it went GA, and it is disruptive in the industry. It solves one of the major problems that we kept running across when we were trying to implement digital transformation. So SiteWise offers, it's basically a service that lets me build a model in Amazon. Once I have that model, I can instantiate it, actually creating an asset, and that asset then has measurements. So literally now I've got the ability to build a model, instantiate it in SiteWise, and then be able to populate that asset with measurements that go directly into a time series database. So now I've got this model in the cloud service that really understands what I'm trying to do at an operational level. So I'm going to go into a little bit more detail now. Kurt covered Sparkplug. And one of the things that came out, actually, and it's interesting, it actually came to the forefront in working with Thomas and the SiteWise team, in the fact that Sparkplug already had this ability, but we weren't leveraging it yet. So I'm going to kind of step through what does Sparkplug do and go a little bit into this topic namespace that Kurt was talking about. So the first thing that Sparkplug does is it defines a topic namespace that we can all agree on. Now, if we know a topic namespace, well, what is the advantage of that? Well, that means that I can have an application connect into an MQTT server and do a wildcard subscription. I don't implicitly need to know all of the topics that are there now because I've got a definition. And with that, I can get this notion of a group node device ID. Well, when I get that message, I said, I know where this message came from. Now I get another message, and that's a birth message, and that means that I've got new nodes or devices that I can discover. And now I know that they're available to me within this MQTT infrastructure. Then I've got these messages called data messages or data messages, and that means that a node or a device in my infrastructure has a new measurement, a new process variable that he wants to update, because we can do report by exception publishing of information now. Then the D command and in command topic namespace means that I can set up bidirectional communication so that I can indeed, from an operational system, publish a command to open a valve, start a process, send a new set point, and then I've got my death messages as part of my topic namespace, which is kind of the bookends between I've got a birth, the device is out there, it's online, to the point where I have a death, where an operational system looks at a death message and says, I need to set all these tags stale so that the operators know that that is no longer online. And importantly, in the SiteWise is that death message tells me that I should set the quality in all of the measurements on SiteWise as bad, because I want that source of truth in Amazon's SiteWise service as well. Now, the next thing and this was the kind of the epiphany that we had, is we already had the ability to define model and assets in our publish messages. So the Sparkplug template definition allows a birth message to find a data model. Then the template instance, if you will, allows birth messages to create associated assets from these models. So think about this. Now we've got the ability for a device all the way at the edge of the network to create a simple MQTT message that results in the model and the asset being published, so that now I've got that single source of truth, and I don't have to keep recreating my models at the operational level and at the cloud level, and then another application subscribes to it. We've got to do that again. No, we've got to take it all the way back to the source so we have a single source of truth. Then we define, as Kurt said, efficient binary encoding of process variables objects. So we've gone from this notion of key value pairs, whether it's Modbus or Allen Bradley or Omron or BACnet or ABB protocol or whatever. We always had this notion of just a register number and a tag value. Well, now we've got a proper process variable object. It's got a name, value, timestamp, data type, engineering unit ranges, quality, and now with Ignition 8, we've added to that. We can add any custom property that we want to these process variable objects. And that means that I can publish a temperature because of the topic namespace. I know where it came from. I know what model it goes into. I know its engineering units. And a year from now, when I go back and get that temperature process variable, I know everything I need to know about it right there. And then lastly, we define MQTT state management. Well, proper state management means that I can do report by exception. I've got a pressure value that I'm reading, let's say, all the way at the edge of the network once a second, but it may not change all day. Well, as long as I have state, I know that the value that I've got in my operational system, the value I've got in SiteWise is the latest value. It's got for bidirectional command and control, I've got to have state because I don't want to have a dashboard that lets me open and close a valve, and then the cellular network went down, the VSAT network went down, the factory network went down. Well, if I don't have proper state management, then an operator might think, oh, I can go ahead and open and close that valve, when in fact, that device is offline. So proper state management gives us that bidirectional command and control that we need for an operational system. And then finally, to Kurt's point, is that 4 years ago, we were quite, when we started looking at Ignition and all of these SCADA HMI packages, everybody knew that if you're using poll response and your network goes down, you're going to have gaps in your database. You're going to have gaps in your time series data. But now with MQTT and proper state management, we know when the network went down. The edge of network devices can now go into store and forward mode. We've got process variable objects that contain timestamps. So now we can do store and forward, put all of these objects that we were going to publish into a queue. And when our MQTT network comes back online, we now can publish those process variables. And now we can backfill our time series database and keep going along with no gaps in our data going forward. Now, given that definition and the fact that we've got an Ignition gateway here, and with standard Ignition, I've got all of my OPC server client, I've got Allen Bradley, Modbus, Siemens, DMP, BACnet, we've got flow computer protocols, then I've got the ability to connect to all of the devices in the factory at the remote sites and bring those into Ignition as tags. Now, once I have those tags in Ignition, I can define user data types, UDTs. Well, let's come over here to the left and look at a UDT. Well, if I look at SiteWise, it's got the notion of a model, asset, and a measurement. Well, if I create an Ignition UDT, I've basically created a data model. Once I instantiate an Ignition UDT, I've created an asset. And the process variables in the UDT, which consist of timestamp, the value, all of the things that I can define within an Ignition UDT now become my measurement values. So now I've got this model of being able to leverage all of the tools and the technology within an Ignition platform, be able to instantiate a UDT, and now I can publish that UDT, resulting in being able to automatically publish the model, the asset, and all of the measurements associated with that. So we created a new service and we call it Sparkplug SiteWise Bridge. Now, the SiteWise Bridge leverages native Sparkplug binary messaging. So now we've got that highly efficient process variable representation, and SiteWise can now use that using the SiteWise Bridge. Now, the bridge consumes those Sparkplug messages that I showed you a while ago, the births, the D data, the deaths, and it knows how to convert that and put it into AWS SiteWise. So when we get a birth message, we look in SiteWise and go, oh, we don't have that model, so we should create it. When we have a node birth, we go, oh, we don't have that asset, we should create it. Now that we've created those within SiteWise, subsequent messaging using report by exception, we efficiently push all of the ignition tags into AWS SiteWise as measurements and following SiteWise's tag value, timestamp, and quality notion. So now we've gone from the factory floor, from remote site, all the way into SiteWise, and we want to do that without writing any code. We want to do that with point and click efficiency and auto discovery. So now we have all of that information into SiteWise. We've got this. So we have ignition at the edge. We can configure our models, instantiate those to create assets, and then publish those. So no programming or code required. The SiteWise service running on an EC2 instance within the customer's infrastructure consumes those tags, automatically creates the models in SiteWise, automatically creates the assets, and updates all the measurement in real time using report by exception. Again, no programming or code required. And we get to leverage the SiteWise service, providing a standard interface. Now we've got the data models and providing the underlying time series database for our OT data. So now that I've got my data into SiteWise, I'd like to turn it over to Thomas for a while to explain what can we do with other third-party applications or services within Amazon so that we can augment the operational data that we're putting into SiteWise. So Thomas, I'll pull up your first slide and hand it over to you.
Great, thank you, Arlen. All right, so thank you everybody for your time this morning. Okay, so first I'd like to, let me pull back a couple slides here. Perfect. Perfect, this one right here. So what I'd like to do is just do a quick recap of, sorry about that. Perfect, right here. This is the slide I was going for, Arlen.
Okay.
Great, thank you. So again, just wanted to give a quick recap. Oh, not sure why it's advancing there. Right here, perfect.
Oops,
All right.
I don't know why it's doing that, Thomas. Let me, I guess, Kurt.
Yeah, I'll hold off and you can advance the slides. We can just get back to the,
okay.
Right there, perfect. Yeah, thank you. So this, I want to first give a quick recap on what AWS IoT SiteWise is. The way we can think about this is it's sort of a service that has three components within it. We have a managed time series database under the hood. It's primarily designed for ingesting large amounts of time series data coming from facilities such as manufacturing environments, oil and gas fields, any sort of heavy industrial environments where we have large amounts of streaming data. So that's one
Thomas,
component.
Yeah, Thomas,
yes.
Make sure your mouse isn't in the go-to meeting, and then I'll advance the slides for you.
Perfect. I just pulled it out of the window. Yeah, I'm not clicking.
Yeah, there you go.
Okay, very good. So we have the managed time series.
You'll have to click outside the window as well.
Got it, just did. Okay, that'll look.
There we go.
Okay. All right, that looks good. So there's three components within SiteWise. One is the managed time series database, which holds all the time series data that's streaming in from the edge. The other part is a managed asset model database. And so this is a graph database under the hood that stores all the asset hierarchy information that we want to store. So these are the models and the actual assets we instantiate from the models. So think of ways to make representations to translate, where we've been talking about Sparkplug B. How do we go from representations of assets in Sparkplug B and then represent them in SiteWise. So SiteWise has a managed database to be able to define those models and then instantiate assets from those models. So think of a way to define a model for a wind turbine, and then you instantiate that wind turbine model 8 times to create 8 different representations of a wind turbine at a specific wind farm. And all of those have specific properties, and those properties are updated with data coming in from the edge, and that the property or the values of each of those properties is stored in the managed time series database. The third part is what's called SiteWise Monitor, and this is a SaaS application service that lets you build managed SaaS applications for building dashboards. That's essentially what it is. And it consumes data from the time series database within SiteWise, and it of course has the structure of all those assets that is managed in the database. So real quick, I want to touch on, if we can just go back one slide, Arlen.
There? Yeah. I don't know why it keeps doing that. Let's make sure everybody's clicked out of the window.
Perfect, right there.
I think it's got an auto advance on that slide, Arlen.
Oh,
Maybe
okay.
Presentation mode.
Yep.
Oh, perhaps. Okay. Well, we can just go through these quickly then. I just wanted to give an overview of the 3 different data ingest paths of how you can bring data into SiteWise. The top one here is moving data from MQTT into SiteWise. And so that's the mechanism that we're talking about today. So the Cirrus Link SiteWise Bridge, that's the mechanism that it's using there. So it consumes data from IoT Core into the SiteWise Bridge, and then it uses the AWS SDK to actually provision or update values of properties inside of SiteWise. The second mechanism is using the SiteWise connector that runs inside Greengrass, and so that connects to an OPC server and then pipes data directly into SiteWise. And then the third option is using the AWS SDK to use the SiteWise APIs to directly put messages into SiteWise. And so that's, yeah, we can advance to the next one to see the data egress paths.
Okay, that's up, Thomas.
Let me just try to click.
We're not seeing it forward.
I still see the, there we go, right there. So once data is inside of SiteWise, there's 2 mechanisms to pull data out of it. You can do what's called set the property update feature for each individual property. And so when the value of a property changes, an MQTT message will be published from SiteWise to IoT Core. And once that payload hits IoT Core, you can deal with it however you'd like. You can run it through the rules engine and then send it to a number of integrated services that are supported in the rules engine. The other mechanism is, again, using the SiteWise APIs from the AWS SDK to directly pull data out of SiteWise. So you could either pull time series directly out of SiteWise, or you could actually pull information about the asset models out of SiteWise. And with that, we can go to the next slide.
Okay.
Perfect. And so here's sort of an exploded view of what we were talking about earlier that is meant to illustrate all the different paths, the design patterns that we can use to consume data once it's in SiteWise. So the first path is from Ignition at the edge on the left-hand side, using the MQTT transmission module, publishing MQTT messages to IoT Core using the Sparkplug B specification. And then that data is routed to the Sparkplug SiteWise Bridge, which Arlen gave an overview of. And that's actually updating the values of SiteWise asset properties within the managed time series database in SiteWise. So then the question is, what else can you do with this? Well, first of all, you can add additional data from third-party data sources using the SiteWise APIs at the bottom here. So if you need to enrich the asset models in SiteWise with, say, data from an MES system, you can use the AWS SDK and the SiteWise APIs to do that, to enrich those models. But then once all that data is in there, how do you consume it? So I want to focus on this block on the right-hand side of the third-party app. So that third-party app think of this as the customers or the SI's applications that they want to build to produce business value out of all this data that's coming in from Ignition. So the way to think about this is there's a few different patterns. Number one, like I said, is you can set any individual property inside of SiteWise to publish an MQTT message to IoT Core whenever there's an update. So think of this as you could have a property for a particular asset like a rotating pump. And as soon as Ignition or the pump itself, the PLC, recognizes that that pump is in an alarm state, meaning it's overheated or the vibration values are getting out of an acceptable range, it could publish, change a tag value from a Boolean value from false to true to now indicated it's in an alarm state. When that value gets to SiteWise, that change will trigger a publication of an MQTT message, which will go to IoT Core, and then you can do a number of things. You can route it to a service like IoT Events right here, which it lets you build complex state machines to handle event detection. You're basically building event detection models. So that event detection model could then take in the data of this change in the status of an alarm and do things like trigger an SMS message to alert either through email or an SMS text an operational personnel on site to go deal with the problem. Another programmatic approach is to stream it through Amazon Kinesis data streams, batch it up with a Lambda function, and actually call a REST API that's hosted within the third-party app itself to actually push the data of that event into the third-party app. So that's sort of a push mechanism there. The other mechanisms are more of a pull mechanism. So this first one here would be the third-party app itself can use the AWS SDK to actually call the SiteWise APIs and directly pull data out of SiteWise. So this is things like pulling batch time series data out of SiteWise directly. So you can do that. You can also pull data out of out of the asset model database to pull data out for specific models or assets in SiteWise. So say you need detailed information about the structure of a single model for some application, you can do that, or you can actually just pull the time series data itself. The other option is more of what we do when we want to build data lake type solutions. So we actually have a mechanism. It's publicly available. It's in the SiteWise documentation. You can currently go launch it. And what it does is it spins up a CloudFormation stack, and within that stack are resources to basically periodically pull data out of SiteWise, the time series database, and move it into an S3 bucket. So we have the context of that data and the data itself sitting in an S3 bucket, and then you can use services like Amazon Athena to run queries over that data to help you prepare it to do things like training ML models. And once you've trained those ML models, you can use SageMaker to host an endpoint, an inference endpoint, and so this third-party application could now use these services to train and deploy ML models, and then basically hit SageMaker endpoints to be able to actually get inferences out of data. So you can actually build predictive analytics applications. And finally, this is sort of all programmatic approaches, but these patterns can be used by your data science teams to actually extract data from SiteWise and then build other applications as they see fit. So the idea here is SiteWise is really designed to bring large amounts of streaming data in from the edge, structured in a way where it then can be consumed by third-party applications, like we've shown at the right here, to actually deliver business value to customers. So that's what it's really designed for, and that's why there's a nice pairing with what the Cirrus Link team has done here, because what they've solved is how to provide structure to all that data that's aggregated at the edge, that's converted from a number of different protocols, and actually apply some sort of a standardized format, which is the Sparkplug specification. And I think that matches up very well with sort of the philosophy of what SiteWise does. So I'll pause there and I'll hand it back to Arlen to kind of wrap up here. But that's an overview of what SiteWise does and all the different patterns you can use to extract data out of it and pull it into applications to gain insights out of that data. So Arlen?
Great, thanks Thomas, that was great. So let's with the time remaining here, let's jump into a little demo and see how all this works together. So I've got a couple of scenarios here that I'll run through both of them. One is, I've got a remote asset. One of the things that we're exposing here is the new capability that we've got with a company like Multitech that have LoRaWAN built in. I think a lot of people on this call may be familiar with LoRaWAN and the fact that it's letting us put sensors on things that we couldn't even measure before. And at this remote site, we also might have a local PLC. And so this is kind of the, all the way at the edge of the network, leveraging a product like Ignition Edge and being able to publish that information and the models into Ignition Central. So that's one scenario that we'll cover. And the second scenario we'll cover is a factory scenario where we're using Ignition Gateway. And remember, this does not have to be rip and replace. This can be, I put an Ignition Gateway in and I connect it to my existing SCADA. I connect it to my existing OPC UA servers, and I leverage the protocols within that come natively with Ignition to connect to some of the brownfield equipment that I may already have on the factory floor. Then once I've got all of this OT information, be able to build my models in Ignition and then be able to automatically publish those to SiteWise as well. So let's go into this overall complete demo. So I'm going to open dashboard here to my Ignition instance. Now this is Ignition 8 running on an Amazon EC2 instance and a fresh install. So you can see I got all of my designers, I got my protocols, I've got all that. But if we go down here to the bottom, we can see we've got some of the Cirrus Link Solution modules installed as well. Now, right at the outset here, this is going to be a huge disclaimer. Ignition Designer with Perspective, with all of the tools are fantastic. So I just want to explain, Arlen is not an artist that does high performance perspective dashboards. So please don't look at my dashboards as an example of what you can do with all of the tools that you've got with Ignition. So the first thing let's start with is let's jump out to the edge of our network. And let's take a real quick look at this fact that we've got an edge of network device running Ignition, and it's got a LoRa interface in it. So we would like to, represent that LoRa network and sensors that might be on that network. But instead of just pulling all of these random LoRa tags over, and believe me, within the LoRa community, there's all kinds of representations. Let's start with the basics of building a UDT. So we built this UDT, and this tells us all of the information we want to know that's important about a LoRa network to begin with. What's the gateway ID? What's my RSSI level? What's my signal to noise ratio? What channel did those messages come over? And I can put parameters in here that tells me the device serial number, device type. Now that's important because those parameters are going to become attributes when they go into SiteWise. So now that we've defined a model, let's define a model for a LoRa sensor. This is a radio bridge ultrasonic level sensor. And here's all the important information I need to know about that. Battery voltage, what was my timestamp for my last message, how many messages have I had today, tamper detect. Did somebody open the box out in the field that I didn't know about? So now that I've got those models instantiated, I can instantiate those once I've got them defined. You'll see here that I've got a water tank that that's an instantiation of my radio bridge model, and it's got all of the data updating in real time. Same thing for my LoRaWAN network parameters. So now I've got this on the edge. Let's go to our central Ignition gateway and see what we know there. Well, this is a fresh install. And so I've got this tag provider called MQTT Engine, but I don't have any models and I don't have any assets. So let's go into the configuration of this instance. And we'll go down to MQTT Engine. And it's pointing at my MQTT infrastructure. So I'm going to enable that. And by using Sparkplug, those edge of network devices are able to come in and publish their models and publish their assets and then publish their measurements. And those should automatically be discovered and populated within Ignition. So now I can see I've got some data models here. I've got my radio bridge, I've got my network. So if I go into that edge node, my LoRa group, my Kansas City office, LoRaWAN gateway, and I've got my LoRa device, and I've got my network. So now I can leverage Ignition templates and literally start building out a dashboard based on assets that I've discovered out in the field. So in the same Ignition gateway, I'm going to delete these for right now. I've got this notion of a smart factory. So what I've done is I've taken OPC UA tags and created a machine simulation where, like Chris said in the introduction, I can have this notion of a stamping machine. Now, this stamping machine, the customer, and this is actually a joint customer that Thomas and I have talked to, is that a stamping operation might consist of multiple PLCs. So I've got Modbus PLC, I've got an Allen Bradley, I've got an Omron, I've got all of these weird tag names. I want to combine this into a model that once it gets into SiteWise, it makes sense. So instead of having that, I can use the UDT to come over here to my smart factory. And in that smart factory, I've got a model that I built called stamping operation, where I've taken and combined process variables from multiple machines to create a new data model that is the object, or is the representation of a stamping operation, no matter which factory I'm in, no matter what location, no matter where it's connected. So now that I've got all of this valuable operational information, I've got my wind farms up here, I've got my LoRaWAN network, I've got wind turbines coming from my AWS group, wind farm controller, my wind farm turbine. So I've got this notion of having a wind turbine out there. So now let's go back to our topology. I've got all of this operational information. Now I want to get it into SiteWise. So let's do that. Let's take our MQTT transmission and see how hard it is to configure this. So we're going to go back into our, into our operational dashboard. I keep minimizing that when I shouldn't. And we're going to go down to MQTT transmission, see how hard it is to connect to SiteWise. So I look at my configuration, and you can see here, all I need is the URL of my AWS IoT core, my MQTT broker in Ignition in Amazon, and the TLS certs that I got when I commissioned that. With that, we're going to go to our SiteWise. This is my SiteWise dashboard. You can see here that I don't have any models. And since I don't have models, I can't have assets, right? So let's go into transmission, our general settings, and we're going to enable it. Now, when we enabled that, what happened? We made an MQTT, a secure outbound MQTT connection from transmission to IoT core. Once IoT core got these messages, Sparkplug SiteWise Bridge is subscribed to those messages, and it's looking in my IoT SiteWise, and it's go, oh, I don't have those models. I'm going to create them. So let's go back to our web browser here. Let's go back to our IoT, and let's look at models. Oh, look, we automatically are starting to see models getting built out. So if I go into my wind farm, my wind turbine, you can see that I have a model now. I've got a location, a supervisor, and my attributes, and I've got measurement definitions, and I've got the engineering units associated with those. So now that I have the models, SiteWise Bridge should be building out some assets. And I'm starting to see assets appear. So now I've got assets that are being populated from the models that we've built. So now we can see we're starting to build out the smart factory. So now I've got a conveyor on from factory 1, line 2. I've got a lathe I've got a paint booth. I've got my stamping operation from line 4. I just created stamping operation for line 5. And now, to Thomas's point, I can come in here and go to a portal and actually observe the information. Now, this isn't going to be a full tutorial on the tools that they've got here. That would be a whole nother webinar. But I know I can go into my assets. And again, realize 5 minutes ago, I didn't know anything. Now, 5 minutes on, I've got real-time data that's being populated in a model on SiteWise, and I didn't write one line of code. It was completely using all the tools that I had with Ignition and the capabilities of MQTT and Sparkplug. I can go to my smart factory here and start seeing maybe 3 of the lines all in real time, all updating in SiteWise. Now I've got that information in there. I can have the customer go in and grab that information, third-party applications look at that information and leverage that. Now, it pops up stopped here because binary values, that's just the way the dashboards do that. So finally, real quick, we've got just a couple minutes left before we drop into a question and answer. This is kind of a product preview, is that we're going to have a new module coming out called Sitewise Engine. And now that we know about these models and we've got this capability, wouldn't it be cool if we could have Ignition connect into SiteWise natively, look at the models, build UDTs, and populate Ignition, so now we could take advantage of things like perspective and all of the tools that you've got with Ignition. So we'll go back to our configuration. And again, real quickly, let's go into this new module called Sitewise Engine. And let's look at how hard this is. Okay. I've got to point it at the region that I'm running in, and I have to give it my secret access key and my password. Now I'm ready. So let's go to our Ignition dashboard. Let's fast forward. Let's pretend we're at another location, somewhere at corporate, and we've got this new tag provider called Sitewise Engine. No data models, no assets. We've configured it. We're going to go to General, and we're going to enable, that's going to connect our Ignition instance to SiteWise. Oh, let's run over here real quick and open up the edge nodes on Sitewise Engine, Smart Factory, line 1, and we have all of the information, and these are built into proper UDTs within Ignition. So now we have our wind turbine model built up from the model in SiteWise, not from a native OPC UA or anything like that. And it lets us leverage the templates that we had already built out in Ignition. So now if I go into my wind farm and pull over that wind turbine model, well, guess what? I can instantiate that on the dashboard as well. So that's a quick roundup. I know this was a very quick set of demos. Of course, you can always contact Cirruslink if you want to go into any of this, into any more detail. And what we'll do right now is we will go back to the PowerPoint and put up that ubiquitous last slide, always, that says questions and answers. So Chris, I'll let you moderate.
Thank you very much, Arlen. That's fantastic. Great demos as well. Brilliant. We've had a lot of great questions coming in during that session, but let me just cherry pick a few of them. This is an interesting one. Thomas, maybe you can answer this. Why was SiteWise built, and what problem was it intended to solve?
Yes, thank you. Thanks for that question. So this is probably the best question to ask, because we have other services that kind of deal with bringing data in from the edge. AWS IoT Core is the primary one, and that service itself handles MQTT traffic. So what does SiteWise bring to the table? What we really wanted to focus on is bringing streaming data in from industrial environments, but then putting context to that data. We really felt like the ability to build models of real physical assets at the edge. So real press lines, real pumps, real CNC machines, and then have detailed descriptions of the properties and attributes of those machines, and then be able to link the data that's streaming in with those digital representations of those assets. That is the key feature. So we now have the ability not just to bring the data in from the edge to the cloud, which we could do before, either going through IoT Core, going through Kinesis, uploading large objects into S3. We had all that before, but what's new with SiteWise is that we now have the ability to link the streaming data, really high volumes of streaming data, with the actual context of that data, which is the representation of asset hierarchies at the edge. So that's the real reason we built it. And it dovetails really nicely with partners like Cirrus Link here, which have developed the Sparkplug spec for how to use the MQTT protocol to move data from the edge to the cloud, because they have a well-defined structure for how you model the topic namespace, the MQTT payload structure, and actually even their whole concept of birth and death certificates for nodes and devices, so that they can have all that asset context. And so we take that, what they've done is they've taken that model and married it to what SiteWise uses for a model. And it actually, what the solution presented today is a really good example of how the partner solution developed here by Cirrus Link marries with this new service SiteWise. So that's the real purpose of why we built SiteWise.
Perfect. Great. Thanks, Thomas. A couple of people have been asking me if the slide deck is going to be available. I'm going to drop it into the handout section right now, so anybody can download that. And also, we're recording this session, so if you wanted to give it to somebody else, you'll be able to forward a link to that. Another question here, I think this one's for you, Arlen. How is this technology going to be disruptive in the industrial IoT space?
Well, I think this is disruptive. I mean, having the ability for anybody that has an Ignition gateway today, anybody on this webinar that has an Ignition gateway today, you've got your models. Now you can start on that journey of being able to put that up in the cloud and see what you can do with it. I mean, that's one of the biggest things is people get wound around the axle on, well, how do I get started? We got to have all these meetings. We got to make sure we have everything organized, where what we showed today is that if in 5 minutes I can get a model built and an asset instantiated and have measurements going in to cloud services, and then be able to leverage some of the things like SageMaker, then that's disruptive in the industry. So I think the whole partner team here of Inductive Automation, Cirrus Link, Amazon is going to be quite unique going forward.
Excellent, great. This one I think is a good one for you, Thomas. When it comes to cloud versus on-premise, is there a practical size cutoff? I guess that's meaning when
great
you
question.
Switch from on-prem to in the cloud.
Yeah, very good question. I would say that the size difference is less of an important dimension to kind of make that determination of whether to go on-prem or cloud. I think a more important decision point should be, are there capabilities in the cloud services that will deliver business value that I can't get on-prem? That's the most important one. So for example, do we need to get data into, say, SiteWise in a structured format where we can easily build SaaS applications for building dashboards? So SiteWise itself supports that. Do we need to bring data into SiteWise in a structured format and then make that available in a data lake so we can go ahead and train machine learning models using a managed service like SageMaker? So again, something that's not available on-prem. So I think that's the real question to ask is, do I need capabilities that are in the cloud that I don't have on-prem? Now, going to answer the question directly, is smaller better than bigger? That SiteWise is a managed service, and it's designed to handle extremely high volumes of streaming data. So we have limits that you can see on our quotas page for the service. But we're well aware that some customers might have service or streaming capabilities that we maybe need to expand these soft limits for. We have a lot of soft limits that we can change upon specific customer requests. So it's designed to handle anything from small data ingest volumes all the way up to the most demanding streaming data requirements that we can run across. But again, the key question is, what capabilities do we need in the cloud that aren't available on-prem to help you to deliver business values? That's the better way to make the determination.
Great, thanks, Thomas. So we've got a lot of other questions which we're not going to have time to get to, but we will respond to you directly on those. But last question here for you, I think, Kurt, is I have an existing SCADA solution. How do I get started with testing this out, this new technology out, I guess that means?
Well, you can definitely contact us to give us some help, but from an easy standpoint, all the modules that we have in Ignition are downloadable for free. If you have an existing SCADA system, you can go to Inductive Automation, download these modules in trial mode, connect to your data source. We have the SSB or the SiteWise, Sparkplug SiteWise Bridge. If you want to do a beta system, we can work with you right now in the next coming weeks through our infrastructure. The actual release of that product on the AWS Marketplace is expected to be done in the next 2 or 3 weeks, and you'll be able to put it in a trial mode as well on AWS for a free trial mode to start testing there. But from a standpoint, it's you can download everything, but and set it up in a free mode and get started fairly quickly. But you can definitely contact us at sales@cirruslink.com, and we can help assist you in getting that process going.
Awesome. Well, great job. Thank you very much, everybody. And thank you, everybody, for attending and listening to our message this morning. And we're going to sign off there. Thank you.